So I'm Nick Hodges, I'm the CTO of Cauldron, and so essentially where Joe is in charge of the scientific side of the business, I'm in charge of the sort of technical side of the business. And so, yeah, I was going to give a basic overview of where we are in terms of the tech at the moment, and fundamentally the question I'm sort of trying to answer for you is if you're building an online study today, what works and how can you build it? So to look briefly at where we've been coming from, browsers have a sort of reputation for being bad at timing, and certainly historically that's sort of well deserved. We had these sort of older timing functionality that we could get which were easily tens of milliseconds out from what they really should be. Now that's sort of fine if you're doing normal kind of websitey stuff and you just want to go, oh, let's just wait a few seconds and see if the bank card is cleared or we've found out how many train tickets there are. But for a scientific experiment, clearly that's not good enough. Now there are all sorts of workarounds. You know, people try to put plugins in to kind of get better access to timing on the device. We try and get our participants to download and install something, but this just creates a lot of friction. I mean, it's doable, but what we really want is for our participants just to click a link and away they go, and it all works. So, turns out other people wanted this kind of stuff too. You know, the games industry want to be able to do games in the browser. You know, media companies want sort of whizzy visualizers and beautiful animations which are really nicely synced up and really smooth. And so over time things have gotten better. We now have, so first of all, fundamentally there's just new functionality in the browsers now. So we can get direct access to the system clock. With this one performance.now, in fact, they've actually had to hobble this slightly so you can't perform terrifying hacks against CPUs through the browser, but it's still very accurate. And we can also get at the refresh rate. We can also actually sync our animation nicely to the screen. So all that together, we now arguably have the same kind of timing access you would have in a sort of native application. And I think, to put this in context, it's worth looking at the kind of setup that you'd have here. So on the left, this is your task, with the little gorilla up there, running locally on the machine. So that's a standalone program running right there. And on the right is the sort of browser-based equivalent. So instead, your task is running in a browser on your machine, and then we're pulling some stuff from the server as well. So in both these cases, we're plugged into a screen. We've got some peripherals. So now most screens have a refresh rate of 60 Hertz. That means the screen only changes once every 16 and a bit milliseconds. I'm sure this may well be familiar to some of you who've done the sort of lot of low-level perceptual stuff, but that's our kind of gating factor. We can only ever display stimuli in multiples of 16. In practice, this is fine. 3 of these frames is pretty much on 50 milliseconds, so when we tend to use nice round numbers of 50 or 100, it actually divides very neatly, but you can't do 25, right? You can't do half a frame. You'll either get 16 or you'll get 32. So that's stimuli. What about reaction time? So if you're listening to the mouse or the keyboard, so on a standard machine, certainly on Windows, the USB polling rate, the rate at which it listens to these things, is about 125 Hertz, which means once every 8 and a bit milliseconds. So that means, so your absolute worst case, someone presses the spacebar just after it's done a poll, and you're going to have an effective lag of about 8 and a bit milliseconds. Now, these are clearly within range for a lot of scientific research. You know, these errors are perfectly manageable with. But the key point is these are the same regardless of whether you're running in a browser or not. And so, so we think that certainly now that we've got these up-to-date timing things, we have access to the system clock, you're basically in the same boat as someone just running locally. Another question we sort of get, which kind of comes into the timing side of things, is what about connection speed? I mean, won't my participants be somehow affected by how good their connection speed is, the internet? The short answer is no. So the first point to make is that all of the timing stuff we've been talking about, you know, how long did they, what was the reaction time after when they clicked the button, how long was the stimuli on screen for, that's all done locally on the machine. Your internet connection's got nothing to do with it. In terms of actually displaying stimuli, no, but we just need to make sure the stimuli has been loaded in advance of actually displaying the trial. If you just sort of naively just try and put up a trial which links to an image, then it's going to have to go to the server and get it. And you will get that sort of effect that you're used to on websites where you load a site and all the images pop in, but obviously that's no good. This is a very solvable problem. You just simply need to load everything in advance. So the way we approach this on Gorilla is we have this concept of what we call Lookahead, which is where the first thing we do is we look down the road and say what's going on, and we go, okay, well, let's load these before we actually get there, so that by the time the child comes up, everything's there. So we think that this is basically fundamentally a solved problem now. The basics of timing, displaying stimuli, getting reaction times is looking pretty good. So let's look at some other areas. Audio and video has taken a bit of a... So we can play audio in the browser, you can play video in the browser. There has been a recent change to browsers to... I'm sure you're all familiar with that experience of you're browsing online or in the train or something, and suddenly there's some blaring advert from a tower and you have to hunt through and find which one it is, and terrifying embarrassment. There's been some changes that have come into browsers to stop this happening. So the new rules are that videos or audio tracks that are configured to play either automatically when you load it or by a bit of script running in the background will no longer work. This kind of makes your train journeys slightly less embarrassing, but it's actually kind of annoying for us trying to do behavioural science because quite often we want to do that. This area is somewhat in flux. Our sort of guidance at the moment, if you're literally about to do this, are, first of all, if you can, trigger your video or your audio with a play button. If they click a button to play the audio or play the video, that should work fine. The second thing you can do is that if videos are muted, they can still autoplay. So if you don't actually need the audio bit, if you set your video to play muted, then you should be fine. And the third thing you can do is there are some settings deep in the bowels of your browser where you can re-enable this kind of thing. That's quite possibly practical if you are in control of your own hardware, so if you're using your own laptops or whatever, but otherwise, or you potentially ask your participants to do it. But that's sort of where we are. It's a bit of a mess. Certainly the browser owners have broken quite a lot of things, quite a lot of games and other things on the internet that have basically been hit by this, and I think they're still deciding what the best course of action is. As soon as there's a sort of stable fix, we'll obviously put that into Gorilla and so on, but that's sort of where we are at the moment. Moving on to happier climbs, so the webcam and the microphone you can get at now. So anyone who's got a camera in here or any kind of microphone peripherals, you can get at the video stream, you can get at the audio stream, you can record it, you can analyze it, lots of potential to do there. Unlike the sort of total mess with videos, there's just a nice prompt that says, can I use a microphone or can I use a video? You say yes and off we go. That's our hope for what happens with videos if we can get there. But there's plenty of things that you can do there. Games we touched on, so we now have WebGL fairly standardized across the browsers. You could do really nice 3D graphics there. Lots of things we could do here. And so those are all the kind of potential you can do. And then one other thing that people get concerned about with online research is participant behaviour. Do they get sort of distracted while they're doing their task? We had this nice, intellectual thing they're doing, and then this happens. Clearly, they're not in a lab. Clearly, we can't actually control them in any meaningful way. But there's actually quite a lot you can measure here to try and detect that these things have happened. So if they do click on something else, if they do click on a different tab or open a different thing, you can at least find that in your data, and then you can decide how to handle that when you do your analysis. Right, so that's a very, very quick overview of HTML5 and browsers as a platform. Another question we get a lot of is, well, what about apps? Would this be better as an app? How does that work? So we're going to be hearing from Hugo Spies a bit later, so about the app that he built and got out there, see Hero Quest. So we'll have lots of really interesting insights about his experiences. From our point of view, there are really two big reasons that to really go down the app road. The first is you obviously have absolute control over the device. The browsers we've seen is pretty flexible, there's a lot you can do, but maybe there's one particular thing that you just can't quite get the browser environment to do what you want, and whereas an app would almost certainly let you do it. And the second really big one is obviously offline. We're in the browser, fundamentally it needs an internet connection to work. Whereas if you've got an app, they can go off and complete your task wherever you are. Maybe you're going into schools or places in rural areas where there isn't a connection, and they could do the task there, and then once you've got back to Wi-Fi connection, you could upload all the data. So those are two big gains, if you like. The kind of cost of doing that is, well, fundamentally, if you want it on Apple devices and Android devices, you're going to have to write it twice. And the other thing is the fundamental action of getting your app onto someone else's thing is quite painful. If you go through the stores, or both the stores, Apple and Android ones, they have lots of requirements. You need screenshots, you need review copy, you need icons at 17 different resolutions, and a long myriad shopping list of stuff. The Google is quite quick. Apple still have their manual review process, so when you submit it, it will take 10 days to 2 weeks to actually go through and list itself on the store. Any updates, so if you find there's a problem, they have to go to the store too. It's slightly quicker, but you're still sitting there for days while it's not working. So yeah, and this is compared to they just click on a link. Right, so that's where that is. There is a way, if you are doing stuff on devices, on tablets, whatever, and there is a way to bypass the stores, because that you can have your developer account and you can add devices to your developer account and deploy them that way. That's appropriate if you're using your own hardware, you're giving your tablets out to your participants or something. That way you can bypass the whole store thing, but you can only have a finite number on there, so clearly it's not practical for wide-scale sort of rollout. So that's sort of a quick tour of those two things. The last bit I want to touch on is like, well, this is great. How do I actually build this stuff? So fundamentally, this really comes down to how much time you have, how much money you have or want to spend, and how much programming you want to do. So you can do it yourself. There's loads of open source stuff out there that you can. Clearly, you don't need to start from scratch. There are loads of libraries you can use to get you going. So you can build that, and then you can get in order to host it, there are online things you can use. You can procure a server from your friendly IT department. You can get them from the cloud instead. And then you've got your own machine, you can do what you like with it, and you can choose your favorite hosting stack, and or you need a database, you need an SSL certificate, you need to make sure your database is encrypted at rest and it's backed up and things, and it's legally compliant, and your university's happy with it, and your ethics board are happy with it. Or you can use tools which do all this for you. So Qualtrics, SolarMonkey, I'm sure you've heard of. This is the account we're in with Gorilla, and and the fundamental thing is all of that stuff on the previous slide is done for you, right? You just pay to use their tools, and all the rest of it is already there. Now, one criticism you get about tools like these, which I think Joe's already touched on, is that you can never quite get it to do what you want. You don't have absolute control over it. You can get 9% there with the tools that you've seen, and then there's just one little bit. And Joe's already said it. We try and give you the best of both worlds by giving you tools as far as possible, and you can always put that little bit of script in to just make it, just bend it to your will at the final moment. So that's sort of the kind of tools-based approach. We think that that's where this space is going, and that we're moving more towards a fully tooled future. And that's why we built Gorilla the way we did in the first place. And one of the reasons we think this is that we've seen it in other industries. So I used to work in the games industry, and the time was when every small studio had their own little game engine that they sort of put together. And your artists would use tools to make the 3D models and the animation stuff, but it was up to the code team to kind of stitch it all together. There were some big engines, but they cost thousands and thousands of dollars. No one could afford them. So everyone had to roll their own. What changed things, you were just writing directly to these. What changed was a tool called Unity. And this was a fully featured game engine with a really rich editor. And fundamentally what it allowed was for your games company to focus on all of the actual bits that are particular to your game. All of the underlying stuff, the physics, the rendering, animation sequencing, cutscenes, lighting, the works, it's all done in engine. You can see there's this, I don't know quite what it is, this flowchart on the right, which is like a complicated rendering flow for this cutscene they're building. Their programmers don't need to lift a finger for any of this, right? And this has completely revolutionized the industry. No one in 2018 in the games companies goes, I'm going to make a game. Let's start from scratch and write my own engine. It's like, it's there, it works today. So that's where we think the space is going the way it is. And we think that this kind of tool-based approach gives researchers excuse me, the best of both worlds, right? You have tools to do all the easy stuff, and that gets it up and running really quickly. You can do just a little bit of code when you need to, and you can either do that bit yourself, or you can have us do it. So it's quick and it's easy and it's open to everyone. So that's that. We're busy, obviously, sitting there at Cauldron headquarters, making it better every day. We're looking at some eye tracking coming soon. I mentioned the voice tracking stuff. We're looking at mouse tracking and building all of those kind of things in so that when you want to do a project that uses those kind of technologies, it's there working from day one. Now, before I finish, so there's another platform we've been working on called The Hive, which Dan Richardson is in charge of, whom I'm sure many of you know. We're hoping he could be here today to talk about it, but unfortunately he's out of the country. This is a platform for doing experiments on crowds of people. So very, very short, briefly how it works is the middle one with the nose, everyone would see that on the projector. You'd all have your phones and you have a little dot that you can move around and you can see everyone else's dot. And what we're interested in is how you kind of influence each other when we ask you awkward questions. We've had clearance and welcome to develop this further and make it available more widely. So if that's a sort of platform that interests you, do come and find me on the breaks and ask me about it, because that's something we're going to be doing very soon. Thank you so much. Before I take questions, I'm afraid I have to leave at 3 today because I have to collect my son up for essential firefighter practice. So I can only be here till 3, but do please, if there's anything about Gorilla or the Hive you'd like to ask me, do please find me one of the breaks. That's it.